Again, yeah, I'm Vlad. I will be continuing my videos on GitLab Pages development. I just finished the first one, which was describing how to create a development environment. And in this video, I'll try to go over how Pages works internally, how everything kind of tied together. We have Rails, we have GitLab Pages daemon, we have some kind of storage mechanisms, which allows us to share files between those two. We have API used between them as well. So I'll try to show all this. I'll try to show code and kind of explain how all this works together. I'm not sure how good of a job I will do because I've never done such video before. I don't have any slides, so I'll try to show the project, open some maybe Rails console, and show how, yeah, basically how it all structured inside and how you can debug these things. So I'll share my screen now. This one. Yeah. So this is a Pages job from the Pages project I created in the previous video. And I just downloaded the artifacts archive from this very job. It was uploaded here by Runner. And here's what we have inside. It's just index.html and style CSS file, the same as files as we have in the repository. So let's say we want to understand, like, we have a project and we want to understand where we can find these files. This is actually what GitLab will do when GitLab Pages daemon asks for the recent deployment or something. So I just opened the Rails console here, and I can just find the last project because I created it the last. And every project has a subentity called Pages metadata. Sorry, Pages metadata. And as you see, it has a few things. It has artifacts archive ID. This is a remnant of our transition architecture, so just ignore this. But it also has a Pages deployment ID. And Pages deployment is actually, let me show it to you. So Pages deployment. Yeah, it's just a simple entity which has a artifact zip file. It just copied from the artifacts archive and uploaded to a separate location. So we actually could have used the artifacts archive directly, and we did it when we were transitioning to the new architecture. But now we copy all artifacts to a separate location, just so users can do whatever they want with artifacts. If they want to delete them, they can do that, and their Pages websites will not go down because of that. I'll try to show some code how this happens. Oh, I need to open another project actually. This is my JDK directory, and now I'll open the main GitLab project. It was, sorry, TMP, GitLab development kit, and it was GitLab. Yeah, it will take some time. So basically, every time you run a job, not just run, but every time you job with name Pages and artifacts containing public directory finished, yeah, okay, finishes, you can, yeah, it uploads, it just copies this artifacts, not the job itself, but we have a special worker which copies this artifacts archive to a separate location. So you can just search for the Pages worker. Yeah. And as you see, it just has a single action, deploy, and it calls this service. So we can now go find it, update pages service. Yeah. So this is just an object which receives a project and the build ID. Build ID is right here. So yeah, nothing crazy happening here. So then there is a bunch of validation, and then we just create a pages deployment in here. Yeah, sorry, I just opened this directory for the first time because I just created this GDK, and my editor tries to index a lot of things and kind of slow. So yeah, what it does, it just calculates by a bunch of things. Like we take SHA 256. It will be a cache key in some cases, but yeah, just ignore it. And then we basically just create a deployment. We do some more validations here, and then we call this update pages deployment. What it does is just, as you saw above, we have this, where it is, pages metadata, and it just basically updates these two fields. And just updates pages deployment ID, and then next time someone tries to understand which pages deployment is the last for this project, it will be this deployment. This is how it all works when you're deploying stuff. So nothing special happening here. We're just copying one file from one location to another. It is possible to set up these pages deployments to be stored in the object storage, but from this code perspective, it's all transparent regardless of on where you can store it. But just to mention that, yeah, you can store it just locally on the file system. Also, in legacy architecture, and we had this on GitLab.com, we were having the NFS layer. So we were copying all these files to, yeah, not copying, but yeah, we had this kind of distributed way of storing the files on the NFS, and then Pages daemon could have read them. Yeah, but now it's kind of a duplicate in case, so if you want to run multiple pages servers, multiple GitLab servers, or just separate GitLab and GitLab Pages server, it's highly recommended to use the object storage. You can even configure this inside your GDK. Probably can show this. Let me open another tab. So GDK example YML, and there should be pages directory somewhere here. Oh, not so easy. Oh, actually, it's easy. You see that we have a object store configured for pages. I mean, we have a bucket configured. And then for pages, I guess we have, let us actually, yeah, we have GitLab Pages. I was absolutely sure you can configure it from here. But I guess no, you can't easily configure right now inside the GDK, the object storage. Or maybe it's configured by default if you have this in it, but whatever. We'll see that in a moment when I'll try to show you how it's all stored. And actually, yeah, let's go back here. So I don't know, file. Yeah, we have this file URL. Oh yeah, and you see that it's stored. It's currently not stored on the object storage. It's just stored on the local disk path. And yeah, if we just do this, we'll see, yeah, this file is here. Just to be sure. So just some I don't know, explaining the path here. So this hashed directory just added here because in the past we had pages stored by the domain namespace, by the namespace, which can be a group name, can be a personal namespace. So this @sign isn't allowed in the namespaces. So at hashed just means that you don't we just can't collide. There is no possibility of name collision with actual namespace name, and this is just inferred from the project ID, just a lone hash name, and then it's just standard structure of how we define files in carrier wave, but it always be just a single file in there. So you'll always have these pages deployments, then ID of the pages deployment, and a single file in there. And in this directory, there will be always there is possibility of having multiple deployments at the same time. We don't delete them immediately after. Actually, if we go here, you see that we started the destroy pages deployments worker. And we started it with a delay. I guess it was 30 minutes. Yeah, it's a 30-minute delay. Just in case if pages daemon is still serving from the old file, we don't want to delete it and risk running into 500 errors for users. So within half an hour, pages daemon should actually see the new URL for the new file, and we can safely remove the old one. So in theory, you can have multiple pages deployment per project, but they will be cleaned up after some time. Yeah, so now how pages daemon actually knows what to do. I mean, what deployment to take and things like that. Let's see. Yeah, let's just open the, if you remember from the previous video, I enabled the verbose login, so we should see more logs now. So I'll do this, GDK tail GitLab Pages, and we'll see the recent logs. And then we go and actually visit the page. Yeah, and you see all this is printed just by 2 requests, but this is a verbose login. So, just some events. We get some connection. What else? It's kind of hard to read, but actually, you can see the very first thing it does. It connects to the API. Here's the API URL. So it's API before internal pages. You can simply find this file inside the Rails API internal pages. Yeah, here it is. It just has a single action, get request with null path. And what it does, it just tries to find the pages. What it receives as an input is the host name. So in our case, it will be this root 127.0.0.1 nip.io. And this is a group, basically this is a group domain. I mean, in that case, it's a user domain, but regardless, we care only about the namespace, and groups and users are kind of the same on the namespace basis. So yeah, and then we have this pages project, but we don't send it to the API. We only send this host name as a parameter to the API. Then what happens is that we're trying to find the namespace with this host. If we couldn't find it, we search for custom pages domain. You can actually add custom domains for your websites. And from here, there is no distinction. after running this. We just getting some virtual entity, which is called virtual domain. It's just a way to present things to the API. What it does inside is just going into, actually, I can probably show this. Yeah. If we go to the namespace, there is this virtual domain. I just saw it. Yeah. So what it has is just we have a SSL key and certificate. This is only valid for the custom domains. We don't provide those for the namespaces. And then we have a thing called lookup path. What is lookup path? So as you see here inside the URL, we now only have this pages project. What is pages project is? It's just a project name from here. It is possible to have a multiple namespace. So for example, like in case of GitLab, it will be like GitLab -org / I don't know, subgroup and then some project inside it. So in the it will be here, this will be this subgroup I just mentioned, and then the project name. So it is possible to have multiple sections of the path here referring to different namespaces. And this lookup path actually contains these prefixes. So in our case, it will be how's it called? Pages project. Yeah, it will be a pages project. And then it will just say that, yeah, there is this pages project. And for this pages project, there is a deployment somewhere. And for this deployment, we just provide the URL for the actual zip file, and pages will then serve from this zip file. One thing I actually forgot to mention. Every single namespace, as you see here, root, and probably you already guessed it, can have a multiple pages project. It can be pages project 1, pages project 2. I believe I had something like tests pages project. Yeah, no, whatever. I just had another one before running this test, but I forgot how it was called. So you can have multiple domains, multiple projects bear the same pages domain, namespace domain, sorry. For the custom domain, you can only have a single project. Yeah, and then they will be all different only by these prefixes, and obviously they will have a different deployments. Yeah, as you see, we have this every project. We just go over all the projects who have pages deployed. If you remember from the previous console, I mean, if you noticed in the previous console, on the very first thing when I just asked for the pages metadata, there is a flag called deployed here. So this flag is here just to, like, at some point we didn't have these fields, and this deployed true was the only way for us to determine that pages site was deployed for this project, and we can do that very quickly in the database with a very efficient query, and we have a special index for this. Now it's kind of redundant because, yeah, obviously if you have pages deployment ID, then deployed will be true. But yeah, anyway, we're going through all these projects, collect them in a single JSON, and send back to pages. So let's go back to our pages logs. And there are probably more printed here since I've exited a few more things. What else? Yeah, this is just an API call. So there were no error, and here are our lookup path. This is what I've shown you in the, how to call it, in the code just a few minutes ago. So we have this lookup path. multiple of them actually. In that case, we only have one of them. So yeah, here is a prefix, pages project. Here is a project ID, kind of redundant at this point actually, but we still have it. And then we have a source. Actually, right now we only support the zip source. In the middle of the re-architecture, we supported other sources, but right now we only support zip source. So this field is always zip. And then we have this file. It actually shows you where to find the zip archive. And here, different cases are possible. You see that we have this file prefix, which basically says that you can find this file locally on your local storage located in this very directory by this path. It is possible to have HTTP or HTTPS. And in case of if you use object storage to store files, you'll see the object storage URL here. It will be signed by GitLab instance. I probably can try to show you this somewhere. I'm not sure where. Oh, actually, yeah, I can show. It should be in deployment mode. So there is a model called Pages Deployment. I showed you it already in the console. But yeah, it has multiple things here. And I don't see what I wanted to see here, actually. Yeah, I wonder where it is. It's probably in the lookup path or something. Yeah, actually, let's look for the lookup path. Yeah. So this model is responsible for actually presenting the deployment to the Pages daemon. And in case of let me try to find its prefix deployment. Yeah, there is this source file. This is what we see, I believe, somewhere here. Oh, it's actually, sorry, kind of hard to, yeah, there is this source. Yeah, and yeah, as you see, there is this expire at. So what it does, it just it signs the URL for the file, which is valid for 1 day from now. And then Pages daemon just has cache for these files. It's invalidated much more frequently than 1 day. So yeah, we can safely kind of expose these files to Pages daemon, and we are not trying, like, Pages daemon doesn't have any other credentials to the object storage itself, so it can't read anything but this single file, which it got from the API. So yeah, then we have SHA-256. It's used by Pages daemon as a cache key. So if users doesn't actually change anything, I mean, if we, for example, cache got invalidated and then we try to get this new API response, we see the same SHA, so we know that some other caches can be still used by us. Yeah, I wonder why we actually have it 2 times in here, and which SHA-256 is the valid one. Oh, we actually have yeah, we have 2 projects. Yeah, we have. That's what I mentioned. I had another project. It was called Pages Project Test, not Test Pages Project, whatever. This is what I created before, and it has a separate file and separate SHA and everything separate. So yeah, this is what we get from the API. I probably should go to the Pages Pages code base and show how it all works inside the Pages daemon. So it's kind of tricky to get from the first time, but the Pages code base isn't big. So even though maybe code right now isn't in the cleanest state possible, it shouldn't be that hard to find what you need, especially if you use smart IDE, which shows you where everything is called from and stuff like that. So there is a file called appgo, and there is a build handler pipeline. Actually, we need to move this somewhere, but whatever. What it does is, yeah, Pages is just a web server. It listens on a bunch of different ports. It supports multiple ways of basically listening, accepting requests. It can accept HTTPS requests and terminate SSL by itself. It can accept normal HTTP requests. It can accept proxy v2 requests. We need this because we want to have a hub proxy as a proxy server on our production, but we still want to know the real IP of the user. So this is why we're using proxy v2. And it also supports HTTP proxy. It's kind of different from the normal HTTP because when you use HTTP proxy, you can supply some proxy headers, which are again showing what IP was the real user and what domain was requested, stuff like that. So normal HTTP and HTTP listeners just ignore these headers, but whatever. In the end, there is this pipeline of handlers which kind of processes everything, every single request which you get from Pages to Pages. There is a bunch of stuff. I'll briefly go over some of them. So reject methods, it's just a security fix for people trying to send HTTP methods and HTTP requests with long method names like get and there are a lot of letters there. Then we have URL limiter. It's for the same reason, for some people trying to abuse us. Correlation ID is used by us to, it's injected in logs, it's injected in API calls, and you can then use it to find how a single request was processed and all the logs which were related to a single user request. Yeah, this is just handling some panics. What else? Also some, but correlation ID stuff, custom headers, it's just a small feature which allows people to set a custom header on a server-wide basis. So I don't know, if you want to add some header which will be added to every single request response from the GitLab Pages, you can do that via config file. Health check middleware is just used to reply that we are okay and able to receive requests. It's, I guess, mainly right now it's being used by the Kubernetes installation just to make sure that, yeah, this server is actually up. We can now send requests to this instance. Rate limiter is what we currently introduced to get rid of some bogus requests, basically some denial of service attacks and stuff like that. Then there is interesting middleware. This is routing middleware. If we go inside it, this is actually what happens. Like we see this API call. Routing middleware actually does this. What it tries to understand is that where we want, like, what the project is responsible for serving this particular URL. So we just get in the domain and host, and then, yeah, I guess there is a source. source object is basically some, for now, you can just think of it as just a abstraction over the API layer, which takes the host name and responds with some domain object. Yeah, and this domain object then will contain all the lookup paths we saw. So it will basically contain all these API response, I guess, up until here. Yeah, it will contain all this API response, and it will be then used to process the requests. So if we go inside, it probably in interface. Yeah, but we actually need this GitLab source. GitLab source is what is proxying, what is getting the real answer from the API. This parent source is just an interface, and this is what we use to run and test. So this GitLab source is what we need. So GitLab client is just abstraction over the GitLab API. And yeah, then we get this lookup object. Yeah, it contains, as you see, certificate, K, and yeah, some other stuff. There is I won't go into details in here. If you're interested, you can look into this code more. I don't know. You can look into this code more and read how all this works. It's kind of a complicated logic, a bit just the way it's written, but you can see that we have a cache in this. Yeah, in this GitLab source, it's an object. It contains a cache for all the responses we get. And the way it works is that every time we have a new request for the new, yeah, not like for the just a new request for the new resource or something, we go to this cache, we go to this object, find the something in cache, just a like resolvable object. It may not be yet resolved, but yeah. We just get it from here. So if there are multiple clients requesting the same domain at the same time, they all will get the same object. This is object then will call the API, and it will be kept in cache. Cache actually has two things, like two configurations, yeah, basically two timeouts. One timeout is for refreshing the cache and one for actually evicting the cache. So for example, we can have a timeout for refreshing the cache every 5 minutes or every even like 30 seconds. And I guess by default, it's closer to these values. It's defined in seconds, not minutes. And we have eviction cache timeout much longer. It can be like 10 minutes, 20 minutes, 1 hour, or whatever. The way it works is that if new requests comes to us and we have some response, old response from cache, we'll just respond with using this one. Even if something got updated, we won't know about this. But if the refresh timeout has passed, we'll go to the, we'll just asynchronously schedule new requests to the API. So if 10 seconds has passed from the last request and cache is kind of old, we still use it to show the latest information we had, but we'll refresh it in the background, and the new request, which like it will be a third request, will actually see the new data. If new deployment happened or Pages project got deleted or something. So this is why we have two caches, like two timeouts. It allows us from one side to serve traffic without any delays, but also have up-to-date information if something has changed in the API. So I won't go into the cache logic here, but yeah, this is where we get the information from the GitLab API. And this ultimately what this routing middleware does. It just, no, actually it does a bit more. It gets domain, oh no, actually, yeah, it just gets a domain object. Then it's stored, as you see, we have this request, yeah, somewhere a request with host and domain. So we just utilize the context feature of Golang requests. We just put the host and domain object we got from the API into the context of the HTTP request. And then every middleware which is down the line can actually just use this domain object. Yeah. So metrics middleware just reports some metrics. Access logger, I guess, speaks for itself. Acme middleware, just ignore it. It's something related to the generating automatic SSL certificates via Let's Encrypt for our users. It basically just redirects to the GitLab instance in some cases. It's a very simple middleware. Then there is authentication middleware and authorization middleware and auxiliary headers middleware. All they are kind of all work with authentication on the, we have a feature called access control inside GitLab Pages. So what happens there is that we just go, yeah, we just basically implement the OAuth 2.0 protocol with GitLab, and we authorize access to every single project. I mean, if it is protected by default, public projects aren't protected by the access control, private projects are protected, but by default, I believe access control is still disabled on the instance level, so clients need to actually enable it and run some stuff. And on the dev instance, it's not that easy. You won't have it out of the box. Yeah, if you need it for something, just ask someone who already worked on the pages. We'll help you to set this up. So finally, we arrive into this function, which is called serve file or not found. What it does, it's actually serves the file from this zip archive we got. So I remind you that we can get a file on the disk, on the local storage, and we can get it in the object storage by the URL. But from here, it's kind of abstracted away. So let's dive into this. Yeah, so we check some authentication. Yeah, actually, there is, no, give me a second. Serve not found. Domain. Oh, yeah, this is what actually serves the file. This is what generates this beautiful hello world page. So if we dive into this serve file HTTP, at this point, we terminated SSL. We did everything, so we kind of don't care. Let's dive into this. Yeah, so domain resolve. What resolve does is that, remember that for every domain in the API response, we can get multiple projects, right? Yeah, I won't, it's kind of hard to show it again, but, oh yeah, because it's here. So per every lookup name, we have multiple lookup paths. So this is what we're trying to do here. We're just basically iterating over those lookup paths. Let's dive into the implementation. There is resolver. Yeah, it's kind of, we have a multiple layers of abstraction here. It's just a remnant of the re-architecture. Previously, we didn't have this API. We had everything stored on disk. So we had this, when we were migrating from one architecture to the other, we created all these abstractions. Some of them are redundant at the moment, and you can feel the urge to remove some of them. It's not that easy, unfortunately, at the moment, but yeah, hopefully one day we'll do that. Anyway, let's dive into this. And you see we have multiple resolvers, but we need, I believe, yeah, this is the abstract class, like abstract interface. This is what we actually need. And as you see, we just go in the for loop, we go over the lookup paths in the domain object, and just compare the prefixes here. And in the end, we just return the serving request object. It's just another abstraction we had implemented, which encapsulates the lookup path, and it just tells you where to actually find the where to actually find the file stored for your file zip archive with all the files for this GitLab Pages website. So this is what this resolver magic does. Let's go back into, I guess, so this domain resolve. Sorry, I got lost a bit here, so let's dive into this once again. We resolved the domain. So from this point, we already know the domain of this pages request, and we know the path. So then we just need to serve the actual file. So request is this serving request object, and it also knows how to. So it's probably the single thing it knows how to do is just to serve the file. So let's dive into this. It constructs another abstraction which is called handler, and then calls another thing, but whatever. We just dive into this again. And there are actually two. There is a single server. Again, ignore the disk names. There is a single server. We always kind of think that we serve from some virtual file system on the disk. So what we do is then we actually try files. What try file means is that we're trying to find the file responsible for this particular HTTP request. So in our case, it will be index.html. Actually, there is a special logic for handling cases when index.html isn't present here. It's kind of almost doing like internal redirects, but whatever. Let's just dive into this one more time. So we finally arrived at the logic which actually serves the files. So what happens here? So again, we try to get the full path of the file on the. Actually, let me speak about the virtual file systems first. So we have this reader object. It's constructed by everything we had in the above, and it has a root method. What it actually does, if we go into this, so when we construct the reader, reader is just abstraction over the artifacts zip archive. It has, it just has a URL to it, and it tries to present an interface showing kind of this is a file system, and you can read from it. It's kind of complex. What we do is that every first time you create this reader, we go and read through whole zip archive. And then we create an index of files in memory cache. We create an index of files. This all kind of, you can find it all in this file, I believe. So, sorry I'll stop scrolling here. So we create this index of files in memory. And then when you try to get the file by name from this root object, we'll just go into this index of files, try to find it there, And if you and if the file is there, we just return the reader writer. Reader read seeker. So yeah, it will depends on if zip archive is compressed or not, but we'll either return reader or read seeker interface for the file, and then you can just use a copy. Just IO copy and send files back to the user, I guess. Yeah. So this root object is just encapsulates the file system. Sorry. Well, let's just jump again. I just don't know how to jump back, so this is why I'm jumping forward every time. So yeah, we have disk. So we have try file. So we get the root, then we resolve path. This is what happens. Let's actually jump into this. So yeah, we try to evaluate symlinks inside this directory, like do a bunch of things actually. We support symlinks inside the zip archives. Actually, let me try to find where this is a try file. I'm trying to find where we actually create an index of all the files. It should be somewhere here. Sure file. Yeah, it isn't. But whatever. It's somewhere in this root logic and reader logic. So, sorry, the result file. So we have this try file. Yeah, once again. So we resolve in the file. Then if we have it successfully found, we just serve it with all these parameters indicating how to serve it. This is just responsible for access control. This is again just a cache key. This is a full path from the request. It's probably kind of trimmed. It's not a full path of the request. It won't include this pages project. It will be just index.html in our case, I believe. So if we dive into this, yeah. So there is some content encoding negotiation, but whatever. We just support serving from gzip and some other file encodings, and you can put them directly into zip archive, and serving from them will be much faster. So yeah, then we actually, this is what I was speaking about, the virtual file system. So we kind of implemented the standard file system methods on this object. So we'll just call lstat on the file, see if we have it. If we don't have it, I guess we respond with we actually should just return false from this function, but whatever. So we try to get the file information, do some content type magic, increase some metrics, whatever. And then just here's where actual serving of the file happens. So if you remember, I mentioned that we can return read seeker or just reader interface. So this is where we have some distinctions from here. It depends, like if the zip archive internally is compressed, we cannot easily seek inside the individual file which is inside the zip archive. So it won't be seekable. But if a file is not compressed, it will be, and it is needed for us to be able to serve the HTTP range requests. So if someone wants to get a specific range from the file, if it's for example a video or audio file, and you want to have this have it scrollable inside your website, then you just need to upload uncompressed zip archive. There is a special runner environment variable which will do that for you. But yeah, in the end, we just have this HTTP serve content, and we pass read seeker inside this. And yeah, from that, it will just work. I mean, this is a standard HTTP serving from the Golang library. It will handle range requests for us. It will handle cache headers for us. As you see, by the way, just what was recently introduced is that we added the cache headers. So we now support ETAG caching. So this HTTP server content will handle this ETAG caching for us and do everything. And this just because HTTP server content requires a seekable interface, we can't use it in cases when we don't have it. So it just basically a copy paste of the serve content function with some modification, just ignoring everything which is related to range requests, but it again supports all the cache headers and other information. So yeah, this is how it all works together. I guess I can show you one more thing about the internals. It's virtual file system. So we have this VFS layer. It's basically, what got this. This is root object is from this virtual file system. So if we go here, VFS is just an interface which supports root object, which supports three methods. This just, you actually don't care about this. Well, what you care about is the root object. And the root, let's dive into this implementation. Oh yeah, it's actually right here. So the root object is just representing the virtual file system actually. So it supports stat on the file. It supports read link because we need some symlink traversal, and it supports opening the file. And it's basically just responsible for opening the files inside the zip archive. And then we have local and serving. So I'm actually not sure if local VFS is still. Oh yeah. So the local VFS will be working with files stored directly on the disk storage where Pages server is running. So in our case, we actually using this local virtual file system because file is stored locally. And then we have this kind of serving VFS. It's kind of strange name, to be honest. Basically, just responsible for the object storage, but we don't care if it's object storage or not. What we get into this virtual file system is the URL. It can be valid for whatever time, but we treat it as just a URL where we can get the zip archive. It should itself allow range requests, because then when we'll be serving particular files from the zip archive, we'll use this range request. So as I mentioned before, we create all this index of files. Maybe it's somewhere here. No, it doesn't look like it's here, but whatever. We just create this index of files in memory. And for every file, we have an offset in the zip archive where we can read it from. So this is why we need this range request support from the object storage. But whatever, every object storage supports this, I think so. If you want test object storage locally, you can get it running with min.io. It's included in the GitLab installation, like I mean, in the GDK installation by default. I'm not sure if it's enabled by default, but yeah. If you remember from the previous video, there is probably a documentation page for like inside the GitLab development kit, there is a folder called doc, and there's probably object storage on min.io file in the how-to directory, which guides you through how to implement this. So yeah, I'm kind of tired after explaining all this. I hope it kind of gives you an overview. Oh, one last thing. I wanted to show the API. Oh, I actually already showed you an API on the GitLab Rails project. So yeah, this is how it all works together. I hope you understood something from this. I'm not sure if I did a good job explaining this. Obviously, if you want to dive into this, it will be best to just pick up a very small issue or something and try to implement it, and you'll get, you'll understand the particular pieces of Pages code base, I believe, quite easily, especially if you, as you saw, I used a lot of these jump into helpers, kind of which my EDA gives me. So yeah, with those, navigating the code base of Pages is quite, it's not that hard actually. It's not always easy to understand why abstractions are there. Some of them shouldn't be there, but they are, again, remnants of the re-architecture. But still, you can navigate through them easily. Maybe it's not that easy to modify them, but they are all kind of, I don't know. I didn't have a huge problem working with them and understanding them. And yeah, ask us with any questions. There is a GitLab Pages channel on the Slack if you're internal developer, or you can just ask where community contributors. I believe we have some dedicated channels for working with community contributors, or you can just create a merge request and pin the Pages developers inside your merge request. Yeah, anyway, hope this was helpful. Have a good day.